All right, let's move over to the discussion on units. And units are very important. In fact, chemistry and physics have specific units for different types of measurement. Here's the deal. Units are one of those things that a lot of students dread, and it's because they don't understand why they're important, right? When you think of a unit, you might think of like pounds. I weigh this many pounds, or my tape measure measures out to a certain amount of feet or yards. And when you get to a science class and you start using different types of units that you're not familiar with, it kind of becomes confusing to you, and you get lost in this sea of, well, I've got to use proper units, I've got to convert to the proper units, but you forget, or you never truly understand why we use them in the first place and why they're so important. So instead of just going straight into the lesson on the metric system, I want to give you an example of why it's so important to keep proper units and to fundamentally understand them in a science class. I've got a picture here of a rover or an expedition vehicle built by NASA that they tried to send to Mars in the late 90s. The problem is, well, it blew up. And when NASA started investigating why this multi-million, if not billion-dollar machine failed, by the way, it was at the feet of the American taxpayers to pay for this mistake, NASA found that there were two different groups of scientists working on this vehicle. One group of scientists used units that we're familiar with today, the inch, the foot, the yard, the mile, pound, so on and so forth. Another group of scientists used the metric system or the SI system. Those two are interchangeable. And, you might have heard of like the liter or the gram or the kilogram or, something like that, right? With the prefix like centum, milli, kilo, hecta, giga even, right? And the problem is, it's okay to use different types of units, but it's not okay to directly convert from one to the other. It was just a bunch of miscommunication. You see, you can't convert directly from milliliters to some other unit of volume. You have to use a conversion factor, right? You can't directly convert from grams to pounds. You have to use a conversion factor. Because of this miscommunication, it caused the machine to not be built properly, and it blew up, right? And so it's important to communicate your units, whether you be working in the empirical system, which is the English Standard System, feet, miles, so on and so forth, or the SI system, which is known as the metric system. So it's very important to know what units you're dealing with. So because we're so familiar with the English Standard set of units, we're really not going to spend much time on them in this video, but in the next video we're going to be doing some conversion factors between the metric system and the empirical system of units. But I want to get you familiar with the metric system in this video. And so I've got a very simple chart here, again representing the SI system, which is known as the metric system. And by the way, it was developed in 1960 in France as the worldwide standard for units. Now, why did we need a worldwide standard of units? Well, think about it. As the world became more industrialized and more, technologically inclined, it became more and more important for scientists to have a universal system of units, right? So if we were developing a piece of technology in America, it was important for a scientist, say in Germany or Australia or Africa or wherever, to be able to understand the units that we were reporting these values in. So it was just developed so every scientist around the world could understand, and we wouldn't have that disaster that we did with the Mars rover. So length. You might think of the yard, the inch, the foot, but in the metric system, the name of the base unit is the meter, and its symbol is lowercase m. Mass, the base unit is the kilogram, and its symbol is kg, right? Now, look at temperature. You're used to Fahrenheit, maybe Celsius, but in the metric system, it's actually the Kelvin, and that's going to come in very handy when we discuss thermodynamics later on. It's got a symbol of a capital K. And there are some other ones too that you see here. All right? And this is the very foundation of the metric system. And again, like I said before this, each country had its own set of units, and it made converting between them very, very difficult. The metric system is based on the number 10. You know, it's interesting because we think, oh, the metric system is so hard. That's why we haven't fully adopted it. But it's a million times easier than the units that we're used to, because the number 10 is very easy to work with. Let me show you what I mean by the metric system being based on the number 10. We have our base unit right here in the center. So right here is our base unit. All right, that could be, well, in this case, they use meter as an example. You remember in the other slide, the meter measured length. And that's denoted by a lowercase m. Well, say I wanted to decrease in size, right? So say I wanted to measure a very, very small object. Well, we can go this way to the decimeter. So we're still keeping the base unit name, the meter, but depending on whether or not we're increasing or decreasing, right, we use specific prefixes. So in this case, the decimeter. And so the decimeter is 0.1 as far as distance from the base unit goes. The centimeter means you're 100th off from the base unit of meter. And again, here the millimeter means that we are 1,000 off from the base unit of the meter, right? Now, you can see this is decreasing in size, right? For example, there are 100 centimeters in 1 meter. So say you had a meter stick, right? It's easier to say this measures 1 meter. There's no point in saying, oh, this is a 100 centimeter stick, right? And again, we're still dealing with the meter, but based off what prefix you use, it tells you whether or not you're measuring a very small object or a very large object, right? Again, and let's think about that a little bit more fundamentally using the meter versus the centimeter. Or I'm sorry, yeah, the meter versus the centimeter. Again, say that you had a meter stick, right? You have a meter stick right here. And obviously, it's 1 meter long. But then say you had like a pencil. And, you know, we'll say that this is the size comparison. This is your meter stick, and this right here is your pencil. It wouldn't make a whole lot of sense, and I'm just making numbers up in my head, okay? It wouldn't make a whole lot of sense to say, oh, this is 0.75 meters right here. Obviously, a pencil is not 0.75 meters, okay? I'm just trying to give you an example. Because a pencil is so much smaller than a meter stick, what the metric system does is it says, well, we can use a different prefix that represents a slightly different number based off the number of 10. And so, you know, instead of saying point whatever meter for a very small object, we can just say, oh, well, this is just 5 centimeters. So it makes it a little bit easier to comprehend or to understand, okay? Now, we can also go the other way. We can go bigger, right? And so a decameter is 10 times, as you can see, bigger than the base unit meter. Or a hectometer is 100 times the size or the length of a meter and 10 times the size of a decameter, and so on and so forth. So the metric system is just based off the number 10. And I've got to say, okay, this has bothered me a little bit. A pencil is just not okay, a pencil's not that big in meters. Say I should have said 0.5 meters or something like that, right? It'd be a whole lot easier just to say that it was 5 centimeters instead of 0.5 meters. But anyway, I think you get what I'm saying there. But I'm sorry for that little confusion. In other words, the metric system makes the combinations of prefixes and base units pretty simple. And again, you've got your prefix and you've got your base unit, whether it be the meter, the liter, the gram, so on and so forth here. And based off your prefix, it shows you the size. So the prefix is essentially your size comparison to the base unit. And depending on what the prefix is, it's either larger or smaller. Now let's use a pretty simple method to memorizing some basic conversions within the metric system. All right. Since the metric system is based on the number 10, every time you make a step, right, you just move your decimal over accordingly. In other words, it's either 10 times larger or 10 times smaller than your base unit right here. All right? And so I'll show you what I mean by that. Let me get rid of this ink here. But again, it's either 10 times larger, as you can see, or 10 times smaller than your respective base unit. By the way, you need to memorize this chart here. It's very, very important that you do. There's a mnemonic device somewhere out there like King, Henry. I can't remember the rest of it, but I do know that like this is chocolate milk or something like that. But you know, you Google or use whatever mnemonic device you want to, but I'm going to be able to, or I expect you, that is, to be able to reproduce this chart on a quiz or a test. Just FYI, it's that important to me. An easy way to move within the metric system, or that is to convert within units in the metric system, is by moving the decimal point one place for each step. So for example, I have 1 liter. I don't know why this isn't writing. I've got 1 liter, and I want you to convert that to centiliters. Okay? 1 liter, and I want you to convert that over to centiliters. Look, I know the answers here. But here's what you're going to do. You identify what you're starting with. You're starting with 1 liter. So find the liter on this chart that you're going to memorize. Well, it just turns out that liter is a base unit in this example. You don't always start at the base units, but here you do. So now we want to go over to centa. Again, we're keeping our base unit same, the liter. We're just going to a different prefix. So let's identify where centa is on this chart, and it's right here. So this is our goal. So how many boxes and in what direction do we have to move over to in order to perform our conversions? Let's see. We're going to start here at our base unit. We got to make 1 jump, and we got to make 2 jumps. So we made 2 jumps to the right. 2 jumps to the right. So guess what we do? We take our number that we started with, and that's the number 1 for 1 liter, and we've got to move the decimal over 2 places to the right. So right now the decimal is understood to be here after the 1, and we got to move it over 2 places. So we got to add some zeros. So we got to add 1 0, we got to add 2 zeros, and we're moving it over to the right. And so as you can see here, that's going to become the number 100, and that's how you do these conversions. Let's do another example. We've got 2 grams, as you can see here. Let's convert 2 grams to kilograms. So how many kilograms are in 2 grams? Again, let's identify where gram is. That's where we're starting with. Again, it turns out to be a base unit, but guys, that's not always the starting point. Now, let's find where kilo is on the chart for you to memorize. It's right over here. Now, let's see how many places we have to jump and in what direction. So, we're going to jump 1 place to the left, 2 places to the left, and 3 places over to the left. So, I'm going to rewrite our number 2 that we're starting with. The decimal is understood to be right here, but we've got to move it over, again, 3 times to the left. So, we're going to move it over 1 place, got to add a 0. 2 places, got to add a 0, and 3 places, right? So in other words, we got 0.002, and we wanted to get to kilograms, and that will be our unit. And that's how we convert within the metric system. Now on a quiz or a test, I'll only give you conversions which are on this chart. So we'll go from kilo to milli, pretty much. I won't give you anything else. I just want you to understand the fundamental concept that the metric system is based off the number 10. See if you can do this on your own. Pause the video. We're going to change 400,000 centimeters over to kilometers. Okay? So again, let's find where centimeter is on this chart. Centa is right here. And let's find, so this time it's not a base unit, but it doesn't matter. So now let's go over and find where the kilometer is, or kilometer, and that would be over here. So we got to move over 1, 2, 3, 4, 5 places to the left. So we got to move over 5 places. I don't know why it's doing that. To the left. Did that put a song in your mind? So we got our number, 400,000. The decimal is understood to be right here. We got to move it over 5 places to the left. So 1, 2, 3, 4, 5. Hey guys, that just turns out to be the number 4. And again, this goes back to the example that I started with, right? 400,000 centimeters. You can estimate what a centimeter is, right? I mean, just put your fingers a very small distance apart. Do that 400,000 times. Well, the metric system says, hey, instead of counting 400,000 centimeters, let's just, do this by a factor of 10, move it over 5 places to the left, and just say, hey, 4 kilometers, right? It's a whole lot easier. So again, the base unit stays the same, but the prefix changes in regard to or relative to the size of the object or the distance in which we are trying to measure. And we can convert to different units, that's for sure, right? And we just did that in this example right here. In the next video, what we're going to do is we'll do some more metric to metric conversions, but I want us to start understanding how to do conversions between the metric system or the SI system over to the units that we're used to today. Standard units, or vice versa, all right? So I hope you got something out of this video, and I'll see you in the next one.